Okay. Chapter number 12, Client Hyper-V. Virtualization is awesome. It allows us to use more of the resources that exist on our systems that we don't necessarily use, because we're not always using 100% of the CPU, of memory, and of other resources that we have on systems. But through virtualization, we are able to do so. A hypervisor is basically the program that will take an operating system and allow it to run. Basically, it turns operating systems into these little programs, because the physical hardware does not realize that we're virtualizing it. It just sees a program is running, like a browser, like Discord. It sees a program running. What's happening within that program is we're virtualizing memory, CPU, and all that. So we have our physical hardware, our physical CPUs, our physical memory, and so on and so forth. We have our hypervisor, which will create these operating system spaces, these computer spaces, and within that we'll install various operating systems and be able to manage them. Because this is all software based, the physical hardware doesn't really exist to the virtual machine. It sees virtual drivers, virtual devices, because it's all software based. So there is a program that is acting like a hard disk. There's a program that is acting like memory, acting like the CPU, acting like the network card, so on and so forth, in order to make this happen. Windows 10 has the Hyper-V capability, so you're able to run a OS within Windows 10 in order to do things like software testing, any demonstrations, any training. This is great as a test. I like virtualization as a testing environment. It is possible to run another virtualization instance within a virtualized instance. That can get a little nutty, because you're virtualizing twice. And as long as you have the resources and capability to do so, it could work. Just know that it might crash too. There are a few items that are not available in the server version of Hyper-V versus the client. So for example, in the server, I can take a virtual machine and replicate it while it's on another server. Can't quite do that in client. It's gonna stay within one physical box. Sleep and hibernate do exist within the host OS and client V, not so much in Hyper-V. Mostly because you don't want Hyper-V to go to sleep. You expect Hyper-V to stay on all the time. Of course, it's not included in home or mobile or any 32-bit system. It has to be 64-bit. It has to have the CPU capability to do virtualization. Hyper-V itself can be its own OS. It's basically a server core with the Hyper-V role and nothing else. You can check before you enable it. You can check to see that everything that you need is there to be able to do this. It is a feature, so you can either do it through PowerShell, through through DISM, or in program and features. You'll need to reboot the computer in order for it to load the necessary files in order to run. So here it is in Windows features. You'll need to click on the root folder and it'll enable all these items in order to install everything you need for Hyper-V. The four main components that any virtual machine needs are CPU, memory, disk, and network. As long as you have enough resources, you can run as many VMs as you can. You could use PowerShell commandlets to manage. You can also have the MMC snap in order to manage your systems. Virtual switches, they come, they're important when we have multiple systems and they need to connect in different ways. You tend to have one switch that'll connect out to the physical world, and then other switches can be virtual. Because again, the virtual machines themselves, when they communicate out through their NIC card, that is all software data. That is not actual, and it's not a real packet that's going out to the world. You can configure it so that everything works within, and you'll see much higher performance than you would in a physical network. But again, it's all software, so it's kind of cheap. Here's your virtual networking. You can create private networks and internal networks that, again, don't need to connect out to the world. One could connect virtual machines to each other or virtual machines to the host. You can, when you create a VM, you have the choice of generation 1 or generation 2. Generation 1 will be for anything that's old, that need, like if you need to run, like, I'm just gonna throw something way out there, like Windows 98, you're gonna use generation 1 versus generation 2, which would be running anything with a UEFI, so like Windows 8 and 10 and any of the latest servers. Here's the difference between generations 1 and 2. If it's Gen 1, it's going to be BIOS based. It won't have secure boot. It'll have an IDE or SCSI. Disk controllers, you can have the old legacy or synthetic network adapters. It'll have a floppy drive. In generation 2, UEFI based, secure boot is there, SCSI only, it'll use synthetic. No floppies. Your virtual machines can have any of these states. It can either be off, running, starting, paused, or saved. When you look into the VM itself, you be able to see the GUI if one exists and be able to interact with it as though it's a physical box. The virtual machine connection can do quite a number of things, from mounting disks to install operating systems to doing checkpoints. Checkpoint, if you've never heard of checkpoint, that is basically snapshot for anybody who's familiar with the VMware world. You could also use the remote desktop client to connect over the network to a virtual machine. Again, I would highly, highly, highly encourage you to not use the RDP protocol in the open internet. It has been breached. It is compromised. I highly, highly recommend not using RDP at all. Your integration services is just the same as VMware's tools. That'll give you the drivers you need in order to allow the virtual machine to work smoothly in its environment. Here are some of the integration services that'll be installed when you add the integration services. So it'll be able to do data exchange. It'll be able to do a guest shutdown. It'll do quite a number of things that makes life easier to work with. And I would recommend installing the integration services into your VMs. Because it is acting as a physical system, you are able to change boot order as needed. Just like you would in the real thing. You can choose what order to boot from. There is an option for dynamic memory, where a system can get the memory it needs or grow on demand as needed. Of course, you're going to need something like integration service already installed before you do this, because otherwise that'll go crazy. And you can choose what VM will get a higher priority if you have multiple VMs running at once. So in this case, we have a machine who has a gigabyte of RAM, but it can grow up to that amount just in case. Now, I don't remember off the top of my head if Hyper-V allows over-provisioning. I know VMware does. And if I had to take a guess, Hyper-V does too. Because we're talking about Windows, primarily as the operating system we're virtualizing, you want to give it 2 processors. If it's Linux, it could run with 1. The maximum 4 CPUs is the maximum physical that you have. So there's the option for that. Again, you can define the limits based on how much we're going to reserve, or the limit or relative weight by other systems that are running. There is a compatibility node in case you're moving this, or migrating should be the word, one VM to another, and the second machine has a different processor. Your hard disks, they are really just files. But just like on the physical systems, if you went with the generation 1, it can only hold up to 4. If it's generation 2, it'll be able to handle more at once. Because they're virtual disks, you can move disks around and not really have a problem, other than, you don't have a boot partition, so it's not going to boot. Two big notes here. If you're going with a VHD file, it can only grow up to 2 terabytes, whereas VHDX is 64 terabytes. VHDX is the newer version of the virtual hard disk with some new features. There is also the VHD set, something that has existed in VMware for forever and a day, where you can take multiple files and turn into one disk. Because we're talking a virtual disk, we can make it grow automatically. As we need more space, it can dynamically expand. You can also set fixed disk size. A fixed disk size is good for things like databases. You can also have things like differencing disks. If you have multiple VMs that run the same OS, they could share the single parent. So basically, we're installing Windows once, and then 3 VMs could share that one base install and make their own from there. That would cut down on setup time. You can do some edits on a virtual hard disk. And these are pretty standard editing that you can do on a virtual hard disk. Networking can handle VLANs. So if we're setting up virtual machines and they're going to connect to the physical network and they have a specific VLANs that they will be able to connect to those networks. And those do get passed through the software onto the NIC card, onto the wire. You can also do a number of things like DHCP guard, MAC spoofing, so on and so forth. Moving machines is generally easy. You can import and export. For the most part, that's the easiest way to get a VM off of one box and into another. Again, you can use, as Microsoft calls them, checkpoints. VMware calls them snapshots. So in case, let's say you have a test machine and you test a new piece of software, you want to do a snapshot before you begin, because in case things don't work out, you can just revert. Hyper-V does have a wizard that you can use to migrate your virtual machines out, and it'll copy all of these items together. The easiest way to make a copy is to export and then import somewhere else. It'll ask you for a unique ID. Make sure that it's different. It'll just save you the hassle. I mentioned all these things about checkpoints. Great for testing, great just in case things go bad, we can easily revert. It's one of the best features of a virtual machine. It'll have everything as that virtual machine was at that point. So if and when something goes bad, it is easy to revert back to that exact moment and resume as normal. If you have too many checkpoints, that can cause some issues, especially when restoring. You wanna manage your checkpoints. So here's an example of having our one machine, and then we have two snapshots. From the second snapshot, we made another one, and that's where we're at now. So just in case we need to go back to test case one, we can do that, and that'll be another chain. And of course, we have some options to manage checkpoints. Any questions? Okay.